All right, so for the next set of questions, we should first figure out what it is that we're doing. What chapter is this coming from? Just by looking at this, I can tell this is a chapter 9 problem. How we are doing a hypothesis test, you can just tell from the first question. It's asking for the null and alternative hypothesis. Because there's only one mu here, that means it's a one sample hypothesis test. So chapter 9. Okay. So the first thing we want to do with these problems is let's write out everything that is given to us. So the average cost of books per semester is $650. Let's come back to this. A survey of 23 of their student customers indicates, so 23 is our n, so n equals 23. They spent an average of $635, so 635 is our x bar. X bar is 635. And the last thing that we have is our standard deviation. And this is population standard deviation because it's sigma. So population standard deviation of 9.45. Okay, great. So that's everything that we have. Now let's figure out what the null and alternative hypothesis is. The key word here in this problem, so I've said this before multiple times in other videos, but typically in these problems, we are given the alternative hypothesis. So right here, it says, believe that their costs are less. So less is that key word. That means our alternative is going to be less than. So that means we are going to have our HA of mu is less than this 650. So I said we'll come back to this. That comes in here, 650. And that means our null hypothesis is going to be mu it's the opposite of this, so greater than. And our null hypothesis always has an equals in it, so greater than or equal to 650. Okay. So we can tell that the answer is going to be B here. That matches with this. Okay. Just quickly glancing at this, we can see that we are using the p-value approach, right? Okay. So let's just take a look here for a second. What does this match up with on here? This is a less than problem. So that's this. Alternative is less than, alternative is less than. So that matches with this one right here. Whenever we do the p-value approach, what are we comparing? What are the two values that we're comparing? We're going to be comparing our p-value to alpha. Those are the two things that we need. So we need for the p-value approach, we are comparing the p-value to alpha. Okay. But to get the p-value, we need our test statistic. We always need our test statistic. So this is used to calculate the p-value. This is a side note, really quick. We're not doing the critical value approach here, but if we did have to do the critical value approach, I'm just going to put this to the side right here. For the critical value approach, the two values that you're going to be comparing are the critical value and the test statistic. Those are the two values that you need whenever you're doing the critical value approach. Okay, well, let's not talk about this right now because we're not being asked about that. Let's do the p-value approach. Okay, so we need our test statistic. That's the next thing we need to calculate. So what's the formula for the test statistic? It's x bar minus value divided by standard deviation divided by square root of n. What is this bottom part? This bottom part is the standard error. I'm hoping you guys recognize that as the standard error formula. So let's first calculate the standard error, and then we can plug in the standard error into this test statistic formula. I think it's much easier to do it that way. So let's first get our standard error. So what's the standard error formula? We said that is standard deviation divided by square root of n. So what is our standard deviation? Our standard deviation is 9.45. So we're going to say 9.45 divided by the square root of n, which is 23. Whenever we plug this in into Excel, we are going to get 1.97046, which we're just going to round to be 1.97. Okay. Now we can do our test statistic. Now that we got our standard error, we can do our test statistic. So the test stat formula is, if you guys remember this from the formula sheet, it's x bar minus value divided by the standard error. Okay, so what's our x bar? Our x bar is right here. So it's going to be 635 minus the value. The value is whatever that's in here in your hypothesis test. So it'd be 650. So 650 divided by standard error. Standard error we calculated right here, 1.97. Okay. Whenever you plug this in into Excel, you're going to get a negative 7.61. Okay. So there is our, I'm just going to put TS, short for test statistic. So there's our test statistic. Now that we got our test statistic, so we said we need our test statistic to plug it into the p-value formula. So now let's get the p-value because we need to compare our p-value to alpha. So let's take a look at this right here. So if you guys remember what we said not too long ago, this is a left tail test because it's a less than problem. So we are going to be looking at this case right here. Are we using this formula or this one? This one's norm.s.dist and this one is t.dist. So we can figure out which one to use depending on what standard deviation we have. If we have population standard deviation, we're going to be using this one. If we have sample standard deviation, we're going to be using this one. So here we are given population standard deviation. This is the same as population standard deviation. So that means we are going to be using this formula right here, norm.s.dist, test statistic, comma, 1. So to get our p value, we're going to do equals norm.s.dist, test statistic, which is negative 7.61, comma, 1. When you plug this into Excel, you are going to get 1.3449 e to the negative 14. So what does this mean? What does this e to the negative 14 mean? So this means you're going to go back 14 decimal places this way. So your number is going to be 0.0000 with 13 zeros. So I'm not going to write out 13 zeros. Just know that this number is going to be very close to 0. So we're just going to say our p-value equals 0. Okay. Let me just move this up so you can see that. Okay. So if our p-value is 0, what is our alpha? We can just quickly look at that right here. If our alpha is 0.01, our alpha is greater than our p-value, right? So let's say alpha is greater than our p-value. And if we look here, whenever our alpha is greater than our p-value, we reject. So the answer is going to be we reject our null. Reject H0. Let me so you guys can see that. I just wrote our reject H0. But we've solved this whole entire problem. Now we can just go in and, put the answers here. So standard error, we calculated that right here. That's that 1.97, so right there. What's our test statistic? That is right here, TS, negative 7.61, negative 7.6. Our p-value, we said our p-value is going to be close to 0, so we're just going to say 0. That matches with C. And do we reject or do not reject? Given this alpha, we said we reject. So there we go.